solving for a system of equations using a 3x3 Cramer's rule isn't that difficult. Let me show you. First, the first thing that we need to do is to make a matrix out of a system. So we take our x values, place them here, a -2, place underneath the y values, and a +1 for the z values. And we do that for each equation until we get our matrix. Now, all we have to do is solve for a 3x3 determinant. I'll show you how to do it. In order to find our overall determinant, all we have to do is follow our signs and the column that we choose. So we know we're going to be multiplying 1, a +1, times a minor determinant, I'll explain that in a sec, minus a 3 times its minor determinant, plus 5 times its minor determinant. And that is how we get our overall determinant. Now, about the minor determinant, how do we find it? Well, our first one, 1, well, our minor determinant cannot be in the same column or in the same row. So we are left with 1, -2, 5, and 3. And that's a 2x2 determinant. We know how to solve those from before. So our 3, well, is not in the same column or in the same row. So we start with a -2, 1, and with a 5, 3. And for the 5, not in the same column or in the same row, so we have a -2, 1, and a 1, -2 determinant. So, let's find out what this equation means. So we have 1 times, well, 1 times 3 is 3, minus 5 times -2 is a -10, minus 3 times a -2 times 3 is a -6, minus 5, plus 5 times a -2 times a -2 is 4, minus 1 times 1, which is 1. Let's solve for the overall determinant. Our overall determinant then, 13 plus 33 plus 15, that equals 61. Our overall determinant equals 61. I'll just put that number off to the side because we're going to need it later on. Now, to find the determinant of x, we basically do the same thing. Except this time, we're going to take all the answers that we had, the 4, the 3, and the -8, and put it over our x column. And we do the same thing that we did before. So the determinant of x equals, well, we start with our +4 times its determinant minus 3 times its determinant plus a -8 times its determinant. Let's find out what these determinants are. It looks like since we didn't change any of the numbers, it's going to be the same. So the determinant of 4, the minor determinant of 4, is 1 times 3 minus a -10. determinant of 3 is negative 2 times 3, so negative 6, minus 5. The determinant of negative 8, that's right, negative 2, 1, or how about negative 2 times negative 2, which is 4, 1 times 1 is 1. So let's put this all together. So our determinant of x is 61 again. Put it off to the side. Let's find our determinant for y. To find our determinant for y, we take our answers, put them over the y column, and we do the same thing again. So our determinant for y is going to equal a positive 1 times its determinant minus 3 times its determinant plus 5 times its determinant. Now the new determinant of y is 1 times its minor determinant, which is 3 times 3, that's 9, minus negative 8 times negative 2, which is a positive 16. The determinant for 3 is 4 times 3, which is 12, minus negative 8 times 1, so negative 8, make that a positive 8. The minor determinant of 5 is 4 times negative 2, negative 8, and 3 minus 3. Let's put this all together. So our determinant for y is a negative 122. To find our determinant for x, we take our answers once again and move them over the x column. So we'll start off the same exact form. Start off with our positive 1 times its minor determinant minus 3 times its minor determinant plus 5 times its minor determinant. Let's find these minor determinants. So we have, for the determinant of 1, we have 1 times a negative 8 minus 5 times 3. For the 3, we have a negative positive 16 times minus 20. And for 5, we have a negative 2 times 3, negative 6, minus 4. Let's put it all together. Our determinant for z is a negative 61. Let's put all of these things together and we'll find out our solution for our x, our y, and our z. To find our solution for our variables, we just put our overall determinant over the determinant of the variable we're trying to find, equals x. The determinant of x over the overall determinant will equal our solution. So we have 61 over 61. That means x equals 1. What about y? Well, our overall determinant is still 61. Our y determinant, however, is a negative 122. That means our y solution is a negative 2. We do the same thing for z. So our solution set is 1, negative 2, negative 1. It's that simple.